So I'm very happy to introduce a bunch of esteemed members of the Delta community. We have Allison, who's a software engineer, TD, who is a software engineer as well, Bart, who is a senior staff software engineer, and Robert, who is a critical Delta Rust contributor. So we are going to take questions, and then if we don't have questions, I will just go hog wild. So please ask questions.
Actually, Matthew, maybe we should do a round of introduction.
That sounds great.
Everyone. I think maybe we should go from that side.
Robert, can you give an introduction, please?
Certainly. Hi, I'm Robert. I got involved in Delta RS, I don't know, 2-ish years ago, 1.5 years ago, something like that. Got embraced by the community and has been great fun doing so. In my day job, I'm what's called a senior digital expert for BASF, a big chemical company, and there I built their central MLOps platform. Yeah.
Go ahead, Bart.
Hi, I'm Bart. I'm a software engineer at Databricks. I started working on Delta itself about 3 years ago, and ever since I've been working on things related to performance of updates and merge into Delta tables. So you may know me from things like low shuffle merge and also deletion vectors, upcoming new feature.
I have talked about deletion vectors in the kernel talk, so if you have deletion vector questions, this is the man.
Hi, I'm Allison. I'm also a software engineer at Databricks, and I've been working on the Delta project for, I guess, about 2 years. I've worked on Delta Standalone and some of the connectors, and most recently, I'm working on Delta kernel, which TD talked about maybe an hour ago.
So the entire Delta 3.0 kernel, all of this 3.0 stuff, a large credit of that goes to Allison to make that all possible. And I don't know whether, I've introduced myself last session, I don't know how many people are new, but I'm TD, I am also a software engineer. I've been working on Delta since its beginning, which is like 6 years now. But in the process, I'm right now both working on Delta as well as learning from industry stalwarts like Bart and Robert, learning new things and figuring out how to do Delta better using techniques from various aspects of the industry, both database side from Bart and Rust side as Robert.
Thank you very much for those introductions. So I'll get it kicked off with a question before going to the crowd, a question that I'm dying to ask. What is a good production use case for Uniform? Like the typical production use case.
Typical production use case.
Typical production use case. Should I go for it?
Well, I can tell you something. Yeah. So there are many organizations that have a variety of systems that they need to deal with. For instance, well, there's a major popular data warehouse that I will not mention here that that has Iceberg support as their major external format, and interoperability between systems that speak Delta and systems that speak Iceberg has traditionally not been great, and every system chooses their own favorite pet format, and then your data is essentially still siloed. So with Uniform, we can break those silos and give organizations the opportunity to have different parts of the organization, have different technology choices, and still work together, or for instance, do migrations. So let's say they're migrating from a product that is in one silo to a product in another silo. They can use Uniform as the medium to do that migration and do it piecemeal instead of in one go.
I see. So if an engine has Iceberg read support and they would like to read in a Delta table, Uniform is going to make that possible.
Yes.
That's great.
Can
all
I
right.
add to that one more thought here? Basically, it has been since the beginning of the inception of the Delta project, it has been, our philosophy has been, do not give the user a burden of unnecessary choices. And one of the choices that the user is having to make, users, organizations having to make is that should I put data in Delta or Iceberg, and what if we make that choice, how is it going to backfire, what am I not going to be able to do? Delta Uniform is our answer to make the choice easier, that if you put it in Delta, you're not missing out on anything. So that is you don't have to choose. That's it.
Wonderful. All right, I'm going to turn it over to the audience now, and hopefully you all can just ask the rest of the questions here.
So it's kind of related to talking about some Iceberg stuff. I've dabbled just looking at Iceberg code a little bit because I was curious how it worked. It seems somewhat similar in kind of some of the kernel approaches of they have their core modules and things that build on top of it. So I'm just curious from your perspective, what are the similarities or differences between maybe that setup?
Very good question. Should I go for it? Okay. So yes, definitely we have learned from everyone on how to design things, how to define cores like that. And while we were designing kernel, we drew inspiration from many places. And one of those sources of information was definitely Iceberg core. But what we learned from it is that there are things that you should not do in order to define some core library like that. Like you should not have overtly complex interfaces that expose all the raw low-level details to the end user. Yes, you can have a library that makes code reuse possible, but if the those interfaces of those libraries is so complicated that it's really hard to understand how to reuse the code, what to plug in where, that defeats the purpose. That's why one of our major goals in designing the Delta kernel was to simple, narrow APIs, not expose details that you don't need to expose.
So can I add something
Please.
to that? So I think Delta kernel has two classes of clients. And when you think of integrating Delta with other systems, wanting to use Delta, there's really two categories. One of them is the advanced systems. Mm-hmm. And you can think of query processing engines, so think Trino and Flink. And so basically the major systems that will want control, they want performance, they want knobs. They want to be able to bring their own memory management, their own everything, their own Parquet readers, Parquet writers, just because they've optimized the heck out of that, and they want that performance also for the Delta experience. On the other hand, there are plenty of situations where you don't have an engine, and you just want to read a Delta table, and you don't want anything complicated for that. So the challenge is really in scaling those two different layers and making that work. So we believe that we've found a way to do this so that all the complexity is optional. You can put in things of yourself if you want, but if you don't, then it's simple. I hope that helps.
Oh, yeah, thank you.
Yeah, I can also just add something really fast. I'm not super familiar with how Iceberg, the core and stuff works, but I think just within the Delta project itself, we can kind of compare what we're doing with kernel now to what we did with Delta standalone before, which was used currently for the Flink connector. What we're trying to do with kernel is really abstract all of those lower level details out of the way, whereas standalone was exposing some of those details, like log protocol details, to the connectors. And I think that from my understanding, the Iceberg core is a little bit exposes more than we are with kernel, whereas we're truly trying to keep it super simple and really just make it need to know information only. And that's just in terms of APIs. I think there's also a lot of other performance reasons, obviously, but yeah.
Thank you. I have another completely unrelated question. So open source Delta user here. Kind of two parts. One, I feel like I saw, but I like blinked and maybe missed it, that there was mention of potentially finally trying to integrate the optimized writes into Delta. I thought I saw that on that slide. So just curious, there's plans to finally try to get those integrated. And a kind of follow-on vague question is, I know this new like liquid clustering thing was just announced, and where does potentially like the concept of optimized writes fit into that? Is there potentially shuffling involved in writing liquid clustered data?
This is good.
I think I can kind of take a first stab at that at the very least. So the Delta Lake, it consists of a transaction lock protocol, and the Delta IO Scala implementation is a reference implementation of the Delta Lake transaction log protocol. So there are certain things that are not in that protocol necessarily. So I'll pass it to TD for more info.
Okay, both, I was having a thought when I was answering the previous question, and this ties in together, but a part of innovation evolution is basically learning from previous mistakes, both your own self as well as others, and do something better. That is what we did with Delta Standalone, Iceberg Core, and we're doing something better. Here, we built optimized write before. We did build some of them before, and we've learned from those mistakes that why those things don't quite solve the end user problem. And that's why we are evolving to building something better for the next iteration, and that is what Liquid is. So Liquid basically will be a combination of all those concepts, optimized write, basically eager layout optimizations and lazy offline layout optimization. The right combination of that is basically what Liquid is. So yes, so while those optimized write, those things are going to be there, I think we're also thinking ahead that how can we do better. And so I think things are going to evolve, and we're still figuring out some part of that story on how things will work and stuff. But yes, your point is absolutely valid that there are things that are in transit that we have delayed because even we ourselves have learned better since those concepts existed that those are not enough. Anything you want to add?
Yeah, that makes total sense.
Okay, cool.
Hi, I'm Brenner Heinz from Fivetran. I was wondering about the new uniform standard. I love it. I think it's awesome. I think it's a game changer. I'm just curious about, for customers with existing large Delta tables, what does it look like can you turn it on right away and start writing in all three formats? And how does that work? Does it start from where you start, or does it look back at the transaction log, see what's in there, and
Can I
then...
take that?
I don't actually know the answer.
Okay. Actually, honestly, neither do I, but I can take a crack at it. So from what I understand, and I wasn't intimately involved with the uniform thing, so I'm totally make an educated guess, is that if your table satisfies certain constraints, that it does not have maps, it doesn't have arrays, which are hard to, the Parquet files that already have those makes it hard for it to interoperate be readable by Iceberg. So within certain constraints, if a table fits within those constraints, then you should be able to convert your table to uniform, enable uniform, and make it readable from Iceberg. Now, the devil is in the details of those constraints, and that is something right now it is in preview, so we are also figuring out some of those details and working with customers et cetera, to understand their requirements and in what fraction of the case are we able to convert versus what fraction we are not able to. So it's all work in progress, but that's the high-level idea.
And to start,
the other part of this, the other part of the question was, I believe, whether the entire table history is converted.
Oh, yes.
So, and I am not able to say with certainty, but my educated guess, based on how these things usually work, is that it's not the case. Because going back through history and converting each of those metadata layers one by one would essentially mean creating an Iceberg table and updating the metadata in a linear way, serially, for all those commits, and stacking those commits on top of each other. Maybe there's a smarter way to do it, but it's a lot of effort to do. And typically, I would say it's not the thing that people are necessarily looking for at that point. They just want to have the state at this point in time.
Yeah. Again, subject to change. It's all about customer feedback, user feedback, and stuff. So whatever the community wants, if it is technically feasible for us to do that without additional burden or huge pitfalls for the customer/user,
and
why not?
of course, there's also the question of what did the table contain in its history. So if the table did contain these array and map types in the future, or sorry, in the past, then
Yes.
you
Does
remove
get
them. So you enable column mapping, you drop the columns, then you would still be constrained by that when trying to convert to uniform in the now, which would be a shame.
Great. And then just one more quick question. I think it's kind of astonishing in a way. You know, I'm so used to talking about the format wars, right? And I think it's great that Databricks is sort of committed to openness and sort of realize that not everyone has a single sort of monolithic stack, right? A lot of companies have both Snowflake and Databricks. And I guess my question is, do you think the other formats are likely to adopt something like this? Is there a reason for them not to, or is there a good reason for all of us to play nice now and work with one another?
That's actually a really good question. And I think a lot of this boils down to...
I did talk to Danny Lee, and I think he mentioned that, I want to say the Iceberg community is very open to implementing that as well, and also reaching out to Hudi. I don't think they're fully committed or any formal commitments out there, but I think there's a lot of openness in the community to adopt this.
Great, I'd love to see it.
The question in all of these cases is essentially adoption. So even with Iceberg, even though there are many connectors for Iceberg, and but like we just discussed, their kernel design isn't necessarily as clean as Delta kernels, so it might be a little bit harder for them to roll it out everywhere. So even if the Iceberg community picks this up, it might be the case that, for instance, you mentioned Snowflake, they might decide to not do this because they're focused on other things.
Like next quarter.
For instance.
I've got another, yeah, go ahead.
I have a couple questions. First one is, do you know about a ballpark of a number of columns where Delta tables start to become less performant or stuff starts to break? Like if I'm talking about like millions of columns, for instance?
Yeah, I can take that. I think the answer to that question depends strongly on the engine that you would use to process the Delta tables. Now, if you're thinking Apache Spark, then there are a number of cliffs in the performance of Apache Spark where the performance goes down when the number of columns grows. If you don't mind me going into a couple of details here, because details I find them fun. Apache Spark has an engine that is based on code generation. So when you have an execution operator that processes data, it generates a piece of Java code, I believe, and then it compiles that into Java bytecode and executes it on the data. And there are certain limits to the size of that bytecode before the JIT compiler will just basically not accept it anymore. I think that even, if I remember correctly, just the JVM size limit on a class is something like 8 kilobytes, or no, 64 kilobytes.
Something in that
8 kilobytes
range.
for a method or something. So there's basically a cutoff where if one method becomes too big, it will stop being able to do code gen, and it will fall back to interpreted execution. So it will suddenly become a lot slower to execute. Next to engine-specific things, there's also problems in the Parquet writing and reading. So, for instance, if you write Parquet with 10,000 columns, then as rows come in, you will actually need a buffer for each of those 10,000 columns to write the incoming rows into. So you get a row, you get a value for every column. You have to write that to the end of the buffer there and decide on how to encode it there. So that's a lot of branches, a lot of cache misses right there. So you can also imagine that there's a cliff where this runs out of cache or TLB, or there's all sorts of reasons why there's cliffs there. Now, you were asking for a specific number. I don't have hard numbers. I know that in the Databricks,
there an order?
There's
Hundreds,
an order.
Thousands?
We have tested Parquet writing in the Databricks Photon writer up to about 20,000 columns. I would recommend staying well away from that number in practice for other reasons. I would probably stop at a couple of thousand to be on the safe side.
That's a couple of thousand for a Parquet file or for a Delta table?
For just a couple of thousand columns in the table schema.
Okay. And second question about the vector deletion. It sounds to me like a trade-off between I/O and compute, and I was wondering, again, sort of like thinking, when does that can I opt out of vector deletion? Does it happen automatically? Like, should I ever opt out of it? Like,
okay, well, actually, in this case, right now, it's opt-in. So because it's actually it's a protocol change, so that means that if we were to make this automatic, then you would run the risk of making the tables unreadable to existing connectors that don't support this yet. So this will change over time, hopefully. I hope that we get, through Delta kernel, get into a state where everybody supports this and we can just turn this on, because it's a fantastic feature in my humble opinion. No.
He's the one who built it, by the way. So.
Yeah, me and my team wrote that feature. So, so as for the trade-offs, we've done benchmarks on this, extensive benchmarking. And so it is always a win at write time, because you can avoid rewriting files just to remove some deleted or updated rows. At read time, the performance degradation that we're seeing is there. It is proportional, roughly, to the number of, or to the percentage of records that are deleted in a particular file. So that means that if you're particularly allergic to read slowdowns, then you can decide to actually set the threshold for compacting that back to 1% deleted rows. And then you're going to get 1% slowdown on your reads. Plus, maybe there might be like a 2% or something baseline. In Databricks Photon, it's actually 0. But in Delta Lake, the open source project, it is about 2%, and that's just because of how Spark works. We can't get around that. But beyond that, you can basically keep this limited to something that you don't notice, and you control when you do your compactions, and then so basically you also control how much rewrites you save. And you have to also imagine here that it's not just about the rewrites that you save. So it's not just CPU, it's also space. Because in Delta Lake, every new commit that you do, where you rewrite files, the old files are actually retained for a full week by default until you vacuum. And that is if you vacuum, because many people don't even think of vacuuming, and so they pay the extra storage cost for their tables, for all of those stale copies of the data for a long time. And deletion vectors reduces the write amplification, as you call it, by such a large factor that people's storage costs will go down. Like, so yeah, in the end, I think the trade-off with the parameters that we've chosen will be such that it's a win for everyone. If you want to opt out, of course, be my guest. But if
like
you have
said,
reasons to opt out,
you don't have to opt out. It's opt-in.
It's opt-in. But once we enable it by default, if you want to opt out, be my guest. It will always be possible to opt out, but then please let us know why, because then we can fix it.
Great questions. Thank you.
Just a reminder, in Delta 3.0, there is deletion vector-based delete. You can opt in, as I showed in my demo in the previous session. You can opt in, you can try it out, give it a spin. If you find any scenarios where the deletion vector-based delete is actually slower than, or the read performance is significantly slower than without deletion vector, please report it to the community. Make GitHub issues and stuff. We want to learn from everyone in the community what are the scenarios where this is not working and stuff, and keep optimizing it continuously.
Great. Next question.
Must be someone.
Yeah. Well, my question will be very close to the ground. But it's still about Delta. So we built. I'm part of retailer. We build frameworks. These frameworks do a lot of merges, and all of this works fine. But we have to enforce not null. So we have to avoid nullability of columns. And we found that, let's say that if you have, think about this. You have a table with one row. This row has one column, and it has value ABC. If you will enable not null via check constraint, it works perfectly. But if you do it through table level constraint, alter table not null for this column, it gives error. And it says that I cannot just do this operation because we see it might be null. And question is it kind of design choice that you cannot overcome, or it is, let's say, or it is might be a bug that we should submit because it's make it a bit annoying that we have to use check constraints for nullability while we could use just native not null on the column level.
Honestly, maybe it's the mic or something. I had a slightly bit of a hard time understanding.
Yeah, I will just
question. So
sorry. Yeah, I'll try to repeat. Not null constraints. We managed to do it through check via check constraints. So just like by given expression, let's say column A is not null. But if you're trying to do it via native way, alter table ABC, set column not null, it fails. And the question is, let's say, is it a design choice or limitations, or it was something which probably will be fixed because.
Okay, so the question's about check constraints.
Yeah.
Is this about
what does it fail
fail as in is a check constraint when the value of the check expression ends up being null, that it rejects your row? Is that the question?
No, the value is always there. And just one column, one record, value is always there. And check constraints, let's say kind of like generic one, always work, we can enforce, but it's for, in our case, it's not perfect because we must use native not null constraints, which is you also, let's say, have it as a part of Delta. But apparently, if we apply them on existing table, it doesn't work. If you apply it on a brand new table, just at the moment of creation, it works. And,
yes, we don't have the ability to check existing data in the table at the point where you add them. That is a problem, and it's not necessarily a choice. It's just that nobody's implemented it yet.
Yeah, okay, so it might come fix it. Yeah, I'm asking because I checked all versions of Databricks and all Delta libraries. If you apply it via check constraints, even to existing data, even 2 billion of records, it's very, very fast. It's like in a minute, scans everything, say it's fine, I apply it.
Does this work in Databricks?
I don't.
I am not aware that this should work.
No. Yeah, it might be that I will connect some of you via example. Because
we will check, and if it's the case, then we will.
That's a bug.
Yeah,
that's a bug in OSS that it somehow is not working. I think what I suggest you should basically make a GitHub issue explaining this exact problem, if possible, like a proper reproduction, and then We can figure it out. Maybe you can fix that bug.
Are you saying like a check constraint applied to an existing table that does not pass the check constraint?
Well, yeah, the table might be existing. It might contain a billion rows. It might be very hard. And because we use merge and let's say we sometimes avoid nullability because, well, for many reasons. And again, if I'll apply a check constraint through the expression, like I will just say column A is not null, then it will be fine. It will say immediately, okay, probably, yeah, I can finish, and we see that this constraint works. But if you will do it through that kind of native way, like alter table, out constraint, sorry, not out constraint, alter table, alter column not null.
Yeah.
That one doesn't work.
Yes. So, yeah, we really would like to see this report as a GitHub ticket, and then we can.
Yeah.
Yeah.
We can follow up on this. I mean, this sounds like a bug.
Yes.
Yeah.
Thank you very much for reporting this.
Yeah, and probably something easier. So I will.
Cool. Thank you very much.
I see that you're trying to simplify stuff. You're trying to make it easier for, well, probably also for yourself. And I see that you use Photon to make delta faster. So writes faster, reads faster. It's good. But can you consider probably just to cancel Photon and make a Photon Rust? So then in the end you will have it's implemented via Rust. Then probably will be a wider audience who can also be part of this. Why? Because yeah, what you do right now is C++. I don't know, is it you or some other team? But if it will be in Rust, it will be comparably fast, but it will be just more accessible.
I can maybe feel that. So we are working with the kernel efforts on supporting a much wider range of protocol features. Yeah, so.
And the Rust community has it's building similar processing engine purely in Rust. Yeah. With higher efficiency and stuff, but it's a more newer community, so it's newer, but it's actually happening, and people
absolutely. I mean, just very recently, Will added Z ordering, which is a feature we're very excited about, a fairly advanced feature. So I would say on the operations side of things, like vacuuming, optimizing, and stuff like that, we're making very good progress. On the protocol side of things, like how many protocol levels we support for readers and writers, I think that we still have some homework to do, but there we're actively working with Databricks. And sort of the approach we take is let's just kind of focus on kernel and then support all of it.
But look, in this case, you have just two engines, Delta RS with own, let's say, features, and you have Spark with own, and question is, why people should suffer from C++, why we have Rust, which can be very
I mean, I can't answer that why, yeah, so I'm a big Rust fan. I think Spark and the JVM and other execution engines are there to stay. Well, there's just kind of multiple communities that like multiple query execution engines, and they're going to be maintained, and I guess sort of the community decides which engine survives and which doesn't. Delta OS on the higher level uses data fusion, which is adopted by InfluxDB IOX, so in a production setting. So I think there we're pretty safe. I think Spark, being somewhat relevant to Databricks, also will remain, but also Trino and other engines. So our goal is to be, you bring your engine and we'll give you Delta data, yeah? So yeah, you choose. And DuckDB, for instance, is something people are very, very excited about as an engine as well. And that's something where we have a great opportunity on the Rust Python side via something we also love, Arrow, to support that as well. So I think for us, the goal is to focus on interoperability, because we don't know who has going to be the great next idea, I don't know, next week, next month. It may outperform everything and should still support Delta.
Exactly.
Thank you.
Thank you for the questions.
There's one in the back.
I have a problem kind of encountered with Delta table. kind of large data volume use case.
Excuse me. Can we increase the volume a little bit further?
Or I can try to speak up closer. A bit.
Yeah, you need to talk closer.
Much better.
Can you hear me now? Or?
A little bit more? Okay, I think it's already better. So please, go ahead. Sorry for interrupting you.
Yeah, so I have a use case where I just have a structured streaming application consuming from a Kafka topic, and we have like very strict SLA for the downstream consumer on this data in the Delta table. But because the data volume is really big, and we have to write the data like every 2 or 3 minutes to S3 and just generate tons of files. And we get to a point where the Delta log, the compacted Parquet metadata file gets like 10 gigabytes level. And every time we try to do very small things, just query a small partition, limit like 100 rows, it will just blow up the driver because they try to grab that files object key to the driver to figure out which file to load. I'm just wondering, there's definitely something we can do on the user side to compact the file, or just don't partition at all, or just like remove older files. But I'm just wondering, like, is there something, or I guess for you guys to consider to kind of improve or create a hierarchy of the metadata?
So yeah, this is kind of a difficult question. So which engine are you using where you're having these problems?
Oh, we actually use Spark to read the data. Yeah.
Yes.
Go for it.
This is kind of a difficult question because the amount of metadata that needs to be processed in as we call it log replay is substantial, and so I think it also depends on the base number of rows that are files that are in your table at any point in time, because in the end what needs to happen is the system needs to read the checkpoint, which contains all of the current state of the table, and then it needs to combine that with the commits that come after it, and figure out what the actual latest state of the table is. And that's kind of an interesting and complicated process that involves joins, etc. And it doesn't necessarily scale terribly well. Now,
by the way,
one of the solutions.
So just to add to that, sorry, I'm interrupting, but just to add to that, it doesn't scale terribly well beyond something like tens of millions of files.
Yeah, we get to like over 10 million files on S3.
Exactly.
That's the point. It. And we've seen this behavior, and I would say it gets faster if you checkpoint, but checkpointing also takes 2 minutes on a table that size. So with these strict SLAs, what would be an appropriate way of dealing with this? I'm afraid that with the current infrastructure, the only way that I can think of that really works is to move older data out of the table into a secondary table, and to keep the tables split up, because or the alternative is to use much larger files. So you can reduce the number of files in your table by a factor 10 by setting the target size to be 10x larger. The downside of that is that you need to optimize your table to rewrite your data. But it would definitely solve this problem.
Can I ask a follow-up question to you? So is it failing while writing from streaming to the table, or is it failing while reading it?
Yeah, it's fail at reading, because when you read that, you have to grab that, check, like compacted Parquet metadata to the driver, and
we're actually coming up on time here.
Let's follow up on that, because depending on the type of failure, it could be the responsibility of Delta having too many files, or Spark. It's a Spark problem as well, because Spark, before querying, tries to keep the entire list of files it has to read in memory, and 10 million files can the thing. So depending on the query pattern, different things are a problem.
Yes, but because the replay should work, and actually during the write, we also do this. So that tells me that the replay is most likely succeeding,
It's
but
the
then
problem, the
it
spark
is
is the problem.
probably not doing enough data skipping so that there's a large number of files.
Again, that
possibly.
depends on the query.
So it depends on the query pattern. So we will be happy to talk with you offline after the session to look at it.
Yep.
So I wanted to thank everybody for coming. Feel free to talk to our speakers over there if you have any additional questions. And thank you very much to the speakers.
Thank you.
Thank you.